Oh yeah. Oh yeah.
Dom and Sam here from Essential RC. Thanks for tuning in for another episode. So the subject of 3D printing, I have to say, I've avoided it. Have not got sucked into it, despite the fact that my good friends Jason, James, and Al have been doing this for a small number of years. Why is that? Why have I been scared about getting into it? Because it's always seemed to be highly technical to me. They're talking a different language when they're talking about 3D printing and all the different configurations they're setting, and sometimes not succeeding and failing with printing. So, but they've been doing it for a long time, like 5 years, I think, and printing some really amazing planes. James bought the P1 Explorer, Abrams P1 Explorer, down last year. A really intricate project, and flew that for the first time. He spent hours and hours printing it and assembling it, and was absolutely terrified when he brought it down to the flying field for the first time. But we flew it and it looked absolutely fantastic. Then James and Al had these electric ducted fan seagulls that they had put together, again 3D printed, and flew those, and those looked fantastic as well. So it's always something that's been in the back of my mind that I've wanted to do, but have not really got into it because of probably the steep learning curve and the time involved in learning how to do it. But just a couple of months ago, Creality, if not the leading brand in 3D printers, got in touch and asked if we'd like to give it a go. And they had this new printer, the CR-10 SE, isn't that right, Sam?
Yeah, that's correct. Yeah.
So tell us about the spec for that, because I thought, well, you know, let's bite the bullet, let's give it a go. So Sam took the printer and set it up.
Yep.
So what's the basic spec of this?
So essentially, Creality of CR-10 SE is you can print at a really high speed as well. I don't know how fast normal printers print, but this one seems you can print up to 600 millimeters per second, which is, you know, you can really churn out some prints if you're printing at that speed and you've, like, you know, practiced and, you know, finessed the print quality, I guess.
And in our first project, we've been printing it up to 100, haven't we?
Yeah, 100. So
and it looks like the printer's going really fast, but it does six times that speed.
Yeah, it's crazy, right?
Crazy.
So if you can finesse the print, then yeah, you can really churn out some prints.
Really, really quickly, yeah.
And the other big feature about the CR-10 SE is that it does auto bed leveling. Other printers like the Ender series, you have to level it yourself, and a lot of people talk about putting the sheet of paper underneath the nozzle and like trying to get that fine gap in between the nozzle and the bed. For this, it goes through and it levels itself, which is amazing. You know, one more step that I didn't have to learn, or we didn't have to learn, right?
Right. Okay, so it's literally press a button and it sets itself up.
Correct.
What about the assembly of the printer? Because it comes in a box, all nicely packed, so it doesn't get damaged on the way to your door.
Yeah.
You take all the parts out, and there are, I think, what, 10 to 15 different parts, and you have to screw those together. Is it any more complicated than that?
No, it really wasn't complicated. The manual did a great job in showing you what you need to assemble and where, and also there's videos on Creality website. I'm sure we can put a link to that in the into the description. And yeah, essentially it came in, the main like two bits were the bed and the Z-axis, the frame, which holds the extruder, which obviously does the printing. So you bolt them in, install a light, and yeah, just connect up all the cables really. The cables are all like kind of labelled to say where they need to go, and that's it.
Oh, okay, that's simple. Okay, so when you got all this set up, you did some test prints. I've got here the very first thing you printed. What's this? Looks like a MiG-29.
Yeah.
Now, I think you misunderstood the brief and you thought that's all we were going to print in terms of aeroplanes, but that's the very first thing you did. And then the ladies were getting a bit stressed about us putting this printer on the kitchen table, so you printed a vase and put a rose in it, right?
Indeed, yeah. I mean, you know, you've got to keep them happy.
Got to keep them happy. And there's some chest pieces in there as well, which you print. They won't come out now. But there's some chest pieces. You started printing some chest pieces as well, didn't you?
Yeah.
So we did that just to check that it did print, and that's fairly nice.
Yeah.
You know,
just how like the quality that we could get from it as well.
Yeah.
And at the obviously different speeds you can print at. Just trying to fine tune your settings to get the result that you want, really.
Okay. So we did that just to check that it was all working. That was fairly quick. But then ultimately what we wanted to get into was printing, 3D printing a radio controlled plane. There are a couple of companies out there that sell the designs, and the designs are, when you buy a design you get a zip file with these STL files in. I can't remember what that stands for, but basically the STL file describes kind of in 3D geometry how it's the design for the components that you're going to print with your printer. So I wanted to select something interesting, maybe that I haven't flown before, so I looked on PlanePrint, one of the two really good companies that are out there. Sure, there are others that I'm not aware of, that provide these designs for not a lot of money. So I selected the PlanePrint Foka, Foka. Am I pronouncing that right? Foka.
How are the viewers want to?
You can correct me in the comments. I'm sure you will. But this is kind of a 2-meter glider, and the other fantastic thing about this, you can decide on the configuration for this. There are different parts because you can decide whether you want it to be towed and released at altitude, or with motor up the front as well. So I haven't done a towed glider before, so that's what we're going for. I've got a number of high wing trainers that can pull a glider of about this size up to an altitude, and then at a flick of a switch release. Yep. And then the second pilot flies the glider, tries to catch a thermal, and then lands. I thought that would be interesting. So we've learnt a lot, right? We're not going to try and claim to be experts. This is literally the first time we've 3D printed something. Right. We've learned a lot along the way. We've done a little bit of reprinting of things that haven't gone so well as we've learned. But I think what strikes us is that once you've got that down, once you've learned how to do it, you can just keep churning out these 3D prints and roll with projects. I've already started on my second and third project, but today we're talking about the Foka 2-meter glider, right? So. Yeah. What have we learned along the way while we've been doing this? We've learned a lot, haven't we?
There's been countless things that we learned. One thing we were struggling with initially was the bed adhesion. So the bed that Creality send out is like a flimsy steel plate that you put on top of the bed, which the bed will heat the plate up, and then the plate was good in one sense that it was easy to remove the print, so you could take the plate off, and as it's flexible you could just like snap it a tiny bit and the print would come off. But what we were struggling with was the adhesion to the bed, where the prints kept falling over, didn't they? And then
because you have to understand, it has to be during the printing process, it has to be stuck on, it has to not move.
Correct, yeah.
In any way, because otherwise the alignment with the print will be off, and it will just create a spaghetti mess.
Yeah, stringy mess.
A stringy mess. So you have to make sure it doesn't move. So the adhesion of the print as it's building up the layers, it has to stay on that bed. Yeah. So we started off with that. And then Jason and James and Al have been kind of supporting us, advising us. When I've gone on our little WhatsApp group and said, it's gone to nonsense all over again, tell us what's going wrong. So they advised getting a glass bed.
Yes.
Because the temperature distribution is better with a glass bed. That was the key thing. And better for adhesion as well. So we did that, and that solved a lot of our problems, didn't it? I think we went a little bit further. Because with some prints, there is not a lot of surface area. Like when you're doing a wing section, for example, there's not a lot of area that it's sticking down on the bed, but it's going to go a long way up. It's going to be like potentially a 3-hour print. So they advised getting some of this kind of adhesive that you put on, spray onto the bed first, 3D lac. So I didn't actually start with that. Wasn't aware of that, so I bought some hairspray. Not that you use much of this stuff these days. And that helped a lot. We haven't had any adhesion problems since, have we?
No, we haven't. It's been, they'll be firmly stuck to the bed, so that's solved one of the main issues.
But then you get the other issue where it can be too firmly stuck, and it's hard to take off. And I was saying this to Jason. He said, Dom, you have to have a bit of patience. You have to let the bed cool down, because it's going up to 60 degrees when it's printing, and you have to, when it's finished the print, you have to kind of leave it for 20 minutes to cool down.
It's like room temperature.
To room temperature. And then it will almost come off by itself without much effort. But if you're a bit impatient like I am, you have to use a standing knife blade to kind of get under it and slip under it and peel it off. Okay. Good. Okay. What else have we learned? I think with this printer, the problem we had was, and you have to understand, the piece of software that you need to do 3D printing is called a slicer.
Correct.
Right. What you get from PlanePrint, for example, is a zip file full of these STLs for the different components you're going to print. But you need a slicer, and the slicer software takes the STL, and you have to tell the software what printer you're going to use, have that selected. Yeah. You also have to use a profile that PlanePrint tell you for the component. And that tells the printer how to configure the printer for the print of that component, yes?
Yeah, correct.
I hope that was understandable. Because some things are internal structures that you want to print, and there are other things where you want a nice surface, like a wing section or whatever. So there's a difference in how you configure the printer for those different types of components, and you have different profiles. Now, PlanePrint are brilliant because they provide 4 or 5 different profiles that you can very easily set up in your printer, but those profiles are geared towards Cura.
They are indeed, because there's certain settings within there. There's like a special mode, especially for the P3 profile, which
surface mode.
Yeah, it's called surface mode, and Cura. They seem to think Cura is the only slicer that offered that.
But it's not.
But it's not. Creality Print offered it as well.
Yeah, and we just thought, well, I thought when we were having problems using Cura and we weren't getting good results, let's try Creality's own slicer. Yeah. So we tried Creality Print, and then you had to basically map the settings between the Cura profile into Creality Print, which wasn't too difficult. You just have to find the setting.
It was the same way as how I inputted the profile into Cura, because with Cura there wasn't any. Well, there was like 2 or 3 preset profiles, but then PlanePrint has a web page called, I think it's, I can't remember what the web URL is now, but it basically lays out all the profiles and each individual setting, like temperature, if you want a brim or a skirt, and special modes like surface mode. And instead of, I basically imported that from Cura into Creality Print, but you can also just go straight to Creality Print and build the profiles that way from the planeprint.com URL.
So once we've done that, we whiz through the printing of these components really quickly, and we've got some of them here. So all the fuselage components here. So let me take this one and the canopy. The really fantastic thing about, and that you appreciate if you're an aero modeller and you've built balsa models, is that the design of this inside for all the servo mounting and how the components interlock together. So for example, this is part of the forward fuselage of the Foka glider, and that's the canopy that sits on top and will be held in place with some magnets, and fits like a glove really, really nicely. That's the thing about 3D printing. Super accurate. Yeah. And the pieces just lock together from one, I think this piece into this piece, is it that way? No, it's the other way up. You can see how they line up absolutely perfectly. Yeah. You know, there are other little pieces that pins that you insert so that when you super glue them together, they line up perfectly, but it's just it's going to be really, really easy to put this together. Great. So, okay. Anything else to say about this printer? I mean, once we got over not using Cura and using Creality print, it's been a breeze, really, hasn't it?
Yeah, we've hardly had any setbacks at all. Yeah, I mean, it's been using the default slicer, and that obviously is linked with the same company as a printer. It was just so easy.
All right, so this is our first in a two-part video about this 2-meter glider. And what we're going to go away and do now is actually glue it all together, install all the electronics, and we'll be back in a minute to show you what it looks like ready assembled. So actually, before we start putting it together, I thought it would be worth showing all the components on the table. So most of this is obviously 3D printed. So you've got the fuselage components. You've got the wing sections, which are slotted onto 6mm carbon tubes. We have got the ailerons, which are both in 2 pieces, and then we've got the horizontal stabilizers and the elevators, the nose piece, and this piece is specifically suited and designed for towing because there's a little hole in the front to allow that. And then we've got the vertical stabilizer and rudder there. What else? I went to my friend George at Formax, and he gave me the electronics that I need. So these are the iTech HS55 servos that are recommended for this. We're not going with a motorized version of this glider. As I said, it's going to be towed up and released at height. So, but I still need to be able to step down the voltage from a 2-cell LiPo to the 5.5 volts needed for those servos. So that's a Beck from George at Formax that will enable me to do that. This is all going to be put together with super glue and Kicker. So I use this mitre bond stuff from Screwfix. Really good deal on that. Got some quick link connectors there. Also an important thing are these magnets, which are going to keep the canopy on and the wings onto the fuselage. So a clever little feature I was showing you. See the little square bit in there, but that's basically where one of the magnets is going to get super glued in, so it can retain it. And I think that's about it. Plus some little components 3D printed, some horns and some other little interconnecting bits, and the dummy wheel as well that it's going to slide along the ground on. So give us a few minutes and we'll be back, and we will have assembled this 2-meter Foka glider. Okay, so here we are. We're back here 2 hours later after putting it together. 2 hours? 2 hours, not 2 hours, not 2 hours at all. I was expecting it to be not take that long. Actually, I thought it might be an afternoon, but I think it took a solid 1.5 days of assembly effort to put this together. But I have to say, I think the result is pretty good if we hold it up to the camera. So to be clear, we've gone with, I think, 3 different reels using this, but it's all PLA, isn't it? And there are different types of filament that you can use, and that's a whole different game. But this is standard PLA, although this one, the red, is PLA plus, actually, isn't it? It was PLA plus, so it's a bit more dense, it's a bit stronger and more durable, and I thought that was a good idea for the fuselage.
Yeah. The grey was a silk PLA, I think.
A silk, that's right. It was a silk PLA and kind of a metallic finish.
Yeah.
And then this was just the standard Creality white PLA to be different. I thought the canopy should look different. And I kind of like the look. It could probably do with a bit more on the graphics, but overall quite pleased. Now, in terms of the important thing, in terms of assembly, how easy was it to assemble after we'd printed out all the pieces? I think it's a lot like putting a balsa model together in some respects. It went together fairly well. There's some really nice design features that enable you to slot it together and interlock the pieces, because the fuselage you see here is in 1, 2, 3, 4, 5 different sections, but with the exception of one joint, which is just a butt joint with pegs, there are very clever lips that they've got on each of the pieces, so that it does slot together and is easy to align. Other things, something else that's quite good is that the push rods are very easy. The tubes for those are actually integrated into the design, so that's very good. Although they do say to use carbon for the push rods, which is not the best material, I don't think. In hindsight, I think that just should have been piano wire, like 0.8mm, 1mm. What else? What else was
for the push rods as well? We put the push rods through before we glued the model together, right?
Yes.
That's one key thing to note, because I think
before we glued the fuselage together.
Yeah, because I think it'd have been stuck. Well, it'd have added more time, right?
Because it's not one tube from front to back.
No,
That's why. Because there's a section where, and I don't know. I'd have to look on the design, on here from PlanePrint, whether that was a printing error or whether that was something that was part. I think it was part of the design. It's not a tube from front to back.
There just wasn't any print there at all, was there? So
no. So there's no guide kind of in the middle of the fuselage for that push rod. So fortunately, we realised that we had 2 1-metre pieces of that carbon rod, and we slotted those through from front to back before we glued it all together. Good point. That was a good catch. What else? I think everything else, it made it pretty easy to put together. The one really frustrating and horrible thing, and I would use that word horrible thing, was the pre-printed slots for the control surfaces. So for example, for the ailerons in the wing, they were not printed very well, and you actually said that it might have been down to the speed with which we printed, because I was in a bit of a rush. We were printing quite quick, weren't we?
I think obviously the slower you go, the
more accurate
the print will be, right? But yeah, I think we weren't printing them very quick. It was about 80 millimeters per second, which is what PlanePrint obviously recommend. They had a small range in there, but we went outside the range, so I think we could have gone a bit slower, and it might have helped a tiny bit, but yeah, it would have helped if the slots were just a tiny bit bigger, I guess. Yes,
it would have, because the actual this is the other thing we didn't mention. So there's another reel that we use, TPU.
Yep.
Is that right, TPU?
Yes, the TPU.
Which is printed, and these are the hinges that you actually print as well, and that's it's flexible material, isn't it? So they're only small little hinges, but you print those as well, and they are quite thick. They're kind of 1.5 millimeter, 1.5 millimeter, I would say, maybe a millimeter. But the slots for those into the ailerons and the wing has to be quite large for those to slot in, and they weren't. There was barely a slot there, so I had to open them up with a sharp blade. And this is the other thing, when you do fit this together, it's a lot like a balsa model. If you put it together, you are having to do little bits of finessing and sanding, and with a sharp blade here and there, with sanding things down so they do fit perfectly. There's a lot of that, and that does take the time. The other thing is using super glue to put this together, and it's unavoidable getting it on your fingers, but you have to be careful that you don't have glue on your fingers and then touch the fuselage, because it is a nice finish after you printed it. And I've got one particular thumb mark on the vertical stab here that really frustrated me. It's like, why did I do that? And the vertical stabilizer is like glued to my thumb and you peel it off and it's got a big thumb mark there, so you have to be very careful of that. But it's a really interesting medium to kind of work with. It's the first time I've done it, and I have to say it's really fun to put together. It's a bit like a jigsaw puzzle, putting it together, and you can do it super rapidly. But you do have to be aware that there are going to be tweaks you're going to have to make along the way as you do it. So we're going to fly this soon. there are two. You could do this in two configurations, either with a motor, speed controller and motor up front with the folding propeller, or towed, and we've gone with the towed version. So the one thing I've got to do is to put an extra servo in here for the release mechanism for the line, because Jason, my buddy, has a big FMS high wing trainer, and he's going to tow this up to height, and then on a switch on my transmitter I will have a release mechanism, so that through the front of the nose there will be like a fishing line. Is it right in the front there?
It's around
just
there,
underneath, I think.
Below my finger or above my finger.
So in line with the thrust line, I will flick, and that will open the servo. It will release the line, and then we can glide around. So that's the way we've gone with this one. Looking forward to that. The one thing I'm really nervous of is some of these joints. You know, is super glued together. I'm just worried about, you know, gliding around might be okay, but no hard aerobatics. I'm worried it's going to fall apart in the air. But I don't know. There is a bit of give there, which is what you'd expect in a glider. Anyway, we will find out the first time we fly it. So that's our first 3D printed RC airplane. Next video in this series will be of us trying, and I hesitate when I say that, trying to fly this for the first time. Looking forward to that when we get, it's winter here in the UK, so it'll be when we get a good bit of weather to do that. We've already started on our next project, and I've also got the third project lined up, but this is one section that I've printed of that second project. Can you guess what it is? If you think you know what it is, maybe drop a comment in the video below and to have a guess at what that is. But going in a bit of a different direction. That's what I love about 3D printed models, actually. Some really weird and wacky stuff out there that you can print. Again, I'll give you a hint, it is from PlanePrint, because they have some really fantastic designs. Yeah, and that's it. That is printed out of lightweight PLA, incidentally, which is a different material. It reduces the weight to 50 to 80% of the same thing that would be printed in regular PLA. So you could even print stuff for indoor models using this stuff. Good, okay, right.
All good.
Anything else to add?
I don't think so. I think we've covered most of it. Or
I think we have, yeah. Just looking forward to taking this out on a nice,
when we can get the weather, I think.
Sunny but cold day and flying it for the first time. So thanks for following Essential RC, whether it be on YouTube or Facebook. We appreciate it, and we'll see you again soon for part 2 and flying the PlanePrint Foka. Or Foka. I don't know, one or the other. Cheers. Bye.
Thanks, guys.